Hello, this is a tutorial to the material file in ASLD. Before I describe the material file, let me mention that ASLD contains or is using three types of parameters. First type of parameters are design parameters, like the property of a mirror inside the cavity. The second type of parameters are here in the parameter file, which are parameters related to simulation. For example, the size of the grid you can increase or decrease. These parameters are all stored in your project when you make save or save as. However, there exists an additional file that's a material file, and that contains all the different materials which you can do for your simulations. This material file is stored in the material file directory, and you can see all these materials and its parameters by clicking on material type. So these are the current materials in the material file. You can add a new one, you can delete one from the list, you can select a certain material for your simulation, and you can also modify the parameters of each material. Let us look to the different material parameters which exist. Most of them are well known, like the thermal conductivity. Then we have some basic physical parameters like specific heat, and we have optical parameters like temperature dependence of refractive index. Next we have parameters related to rate equations. These are important for calculating power and beam quality. And at the end we have parameters related to the absorption of pump light. Here you can make some notes where you got the data from. For example, here the absorption data we mainly got from another file. Yeah, it might be that in a certain simulation you don't, for a certain material you don't know all parameters. This might not be a big problem. For example, the specific heat capacity is used only when you really do a time-dependent finite element simulation. So when you don't know this value in detail, then for stationary simulations, this is not a value which is used. Next, when you go to the optical parameters, you see here concepts like the photoelastic constants. It might be that for certain crystals you don't know them, then you can deselect this and you just don't describe them. And then ASLD also cannot do simulations using these parameters. Another example which is similar is related to pumping. It might be that you don't know the absorption of pump light in detail. In this case you can click here on single frequency absorption, and then all the time the default parameter is used for the absorption of pump light. The third example is related to the rate equations. Of course you have to know if you have some reabsorption or no reabsorption. That means you have a 4-level laser or 3-level lasers, and you have to write down here some basic parameters. But it might be that you don't know in detail the interonic processes. Then you can deselect this, and ASLD is then all the time using simple model for rate equations, which assumes that these transitions are fast. Nevertheless, ASLD is not all the time using all parameters of the parameter file. You can deselect this because in certain cases or in most cases, the simulation is very time consuming when you do a very detailed simulation. For example, what you can do is you can say, I do not want to perform a simulation with photoelastic effect, or you can even make a simulation without the mechanical analysis. In some cases this might be helpful because it's just a time-dependent simulation, and the photoelastic effect might not really be important for your simulation. Another example is this interionic processes in rate equations. Only when you select here use extended rate equations, then these interionic processes are really used for calculating output power and beam quality in rate equations. The third example is related to pumping. Only when you really select use custom frequency dependent pumping, then the absorption of the pump light as a spectrum is really used. Yeah, let me again go to this property of the material file. When you know the absorption coefficient of the pump light in your parameters, you switch on the option really to use that, then ASLD can use this absorption coefficient. To that end, it's additionally important that you describe your pump spectrum. When you don't describe your pump spectrum and you just are saying the wavelength should be a fixed wavelength, then of course ASLD is not able to use the absorption spectrum. It will then use only the default value for absorption of pump light. But you can switch it on and form a very simple model, which means you describe your pump spectrum just by a Gaussian function. Yes, in this case, ASLD uses this pump spectrum, combines it, this absorption spectrum combines it with the pump spectrum and calculates in detail how light is absorbed in your crystal. At the end, let me make some additional remarks to these rate equations parameters. In case of reabsorption, we have mainly a 3-level laser, and then you can describe the emission temperature and the emission wavelengths in more detail. What you also might do is to describe the levels which are important for describing the 3-level properties in detail, and then you can describe these upper energy levels and lower energy Stark levels. And then when you click here on with reabsorption, you can see that using these level descriptions, you can calculate in detail the energy levels. This was done in Ytterbium-Jagd. I should go to that crystal, modify properties. Here you see that the Stark levels of Ytterbium-Jagd are described in detail, also degeneracies, and then the emission spectrum is here described depending on temperature, and also reabsorption is here described in detail depending on temperature. Next, I would like to mention briefly how we can change the system of rate equations. When you click here on interionic processes, then you can describe in detail your system of rate equations. You can describe it by upconversions and cross relaxations. You can increase here the number of levels, also the number of dopings, and you can say that, for example, certain levels, like this level, is not related to the gain medium, but to another medium, another doping, let's say with tolmium here. You can give this level a different name, like E tolmium, or the name 1 tolmium. You can also assign here a certain energy which it has, and then this level also gets another color that you can distinguish the different colors. To describe the set of rate equations, you can insert here different processes like relaxation, effective cross relaxation, energy transfer, and upconversions. I don't want to do that now in detail. And what you have to do is you have to look in detail to your literature, what processes are important for describing the physical effects in your laser crystal. Here, for example, we have described that for a terbium yak, you can see we have here a complex system of rate equations with up conversions and relaxations. For that kind of crystal, we additionally described how much power is how much power contributes to the heat in the interionic process. Um, but in another tutorial I will go in more detail to this parameter. That will be a tutorial on heat generation. Yeah, thank you very much for listening to this tutorial.